Today we are looking at balancing equations. So we'll start off with equations. A process in which one or more substances is changed into one or more new substances is known as a chemical reaction. And a chemical reaction uses chemical symbols to show what happens during a chemical reaction. Three ways of representing the reaction of hydrogen with oxygen to form water. The first of these might be a pictorial representation. So we have two hydrogen molecules reacting with an oxygen molecule give us two water molecules. Another way is to say it with words. Two hydrogen molecules plus one oxygen molecule yields two water molecules. And lastly, we have really what we know as a chemical equation. We have symbols, element symbols, to represent words. So H2 is hydrogen, is a molecule, and we have two of them. 2 is our coefficient right here. Over here we have 1 oxygen, so there's nothing there, so we can assume it's a 1. If I can draw a 1, sheesh. And over here we have 2 water molecules. And again, reactants are on the left, products are on the right, and that is a chemical equation. How to read chemical equations. Alright, so if you're given a chemical equation, how do we say this out loud? Well, really there's three kind of ways that we could say this. The first might be 2 atoms of magnesium plus 1 molecule of oxygen makes 2 formula units of magnesium oxide. And again, magnesium oxide is an ionic compound because we have a metal with a nonmetal. And from our last podcast, I kind of talked about this is an ionic compound, and ionic compounds in their smallest entity are known as formula units. Compounds in their smallest unit are known as molecules, and elements in their smallest unit are known as atoms. So this first way of reading it kind of talks about smallest entities. The next thing we can say is moles. 2 moles of magnesium plus a mole of oxygen yield 2 moles of magnesium oxide. And that's generally the way we'll read these. And then lastly, really what this represents is 48.6 grams of magnesium. And if we look on the periodic table, magnesium is approximately 24.3 grams. But because we have 2 of them, we're going to multiply this by 2. Plus 16 grams of oxygen. How do we get that? Because oxygen is basically 16, but we have 2 as a subscript as opposed to a coefficient. So 16 times 2 is 32 grams of oxygen. Makes 80.6 grams of magnesium oxide. What this does not mean, or how we can never interpret this, is 2 grams of magnesium plus 1 gram of oxygen makes 2 grams of magnesium oxide. So again, these coefficients represent either atoms, moles, or if we're going to talk about grams, we have to use molar masses and usually do some distribution when we're doing our math. Alright, so we cannot say these coefficients never stand for or represent grams. Alright, so balancing chemical equations. Since you've had general chemistry already, this should not be an issue, just a little bit of review. But, number 1, write the correct formulas for the reactants on the left side, and the correct formulas for the products on on the right side of the equation. You're going to see, I think your homework tomorrow, what you're going to do in class is, I think it's worksheet 4I. Alright? But you're going to be doing a bunch of this type stuff. I'm going to give you a sentence equation, and the first thing you have to do is translate it into symbol equation. And once it's translated into symbol equation, you'll have to balance it. Alright, so it's got a little bit of work, but it's great practice for naming and balancing all at once. So ethane reacts with oxygen to form carbon dioxide and water. This is one of our combustion reactions. I think that's how we ended our last podcast as well. But this is ethane, and ethane has 2 carbons and 6 hydrogens, reacts with oxygen. Anytime we have reacts with oxygen, that is known as a combustion reaction. Alright? And anytime we have a combustion reaction with a hydrocarbon, we always get carbon dioxide and water. Second thing we have to do is change the numbers in front of the formulas, which are known as coefficients, to make the number of atoms of each element the same on both sides of our equation. And we cannot change subscripts. So if we want 2 of these, 2 ethanes, we're going to put a 2 in front. We can't change it to C4H12. This is a completely different molecule. This would be known as butene instead of ethane. And we don't even know whether this is a 1-butene or a 2-butene. But either way, it's a butene, not an ethane. Alright? So again, change the numbers in front, coefficients, we don't change subscripts. The PowerPoint's going crazy, I don't know why. Alright, so balancing chemical equations. Step 3. Start by balancing those elements that appear in only one reactant and one product. So if we go back to our equation, ethane reacts with oxygen to get carbon dioxide and water. We've got carbon one place on the left, we've got carbon one place on the right. So this would be a good place to start. We have hydrogen in one compound on the left, we have hydrogen in one compound on the right. And if we look at oxygen, it shows up in three different things, 3 of our 4. So oxygen is probably what we want to balance last if we have a choice. So really, start with C or H, but not O. So if we start with C, we see that we have 2 carbons on the left. How many do we have on the right? We only have 1. So how do we make 2 on the right? We're going to use a coefficient. Alright? And it changes to this. Alright, so we have 2 on the left, we have 2 on the right. Next thing is hydrogens. So we have 6 on the left. How many do we have on the right? We have 2. So we're going to need to use a coefficient, and it's going to be the coefficient 3 this time. And our new equation is going to look something like this. So we have 2 C's on the left, we have 2 C's on the right, 6 H's on the left, 6 H's on the right. And now if we look at our last thing, alright, we're just going to start a new page. Balance those elements that appear in 2 or more reactants at the end. So if we look at oxygen, we have 2 on the left, and over here we have 2 times 2, so we have 4 oxygens here. And we have 3 times 1, 3 oxygens here. Alright? So 2 on the left, 4, and 3. So in order to get 7 on this side, what are we going to have to do? We're going to multiply by 7 halves. Alright? Or you might write 3.5. Chemical equations are written with whole numbers. Alright? So in this case, 7.5 balances our equation. We have 7 oxygens on the right, and we also have 7 oxygens on the left. But because we want whole numbers, we're going to have to multiply and get rid of this 2. So what are we going to do? We need to double everything. So we remove our fraction by multiplying both sides by 2, and we really end up with 2 moles of ethane plus 7 moles of oxygen yield 4 moles of carbon dioxide and 6 moles of water. When might you have to multiply stuff by 2? In combustion reactions. Alright, and this is pretty much the only time you do this. Depending on what you had in general chemistry, you might not have seen these type of reactions. They're about the hardest things that we ever have to balance in chemistry. Alright. Last thing, check to make sure that you have the same number of each type of atom on both sides, and we've kind of done that as we went along.